So learning target 6 is directly related to what we were seeing here in our astronomy part 3. So a quick recap of what was happening there is we were reminded that these spectral lines are like fingerprints because they are all different. No two elements have the exact same spectral lines. We can use them just like we do for people for identification. And this way, we're using it for identifying what the stars are made of. So we had that activity a while back where we were fingerprinting the stars, comparing up and matching elements' lines to that of a star to determine what was in it. Now this part 3 took it a step farther and let us know that we can also use those spectral lines to tell motion relative to Earth. If the star is either moving towards or away from Earth. So that's going to be our focus here for learning target 6, is what do we notice with these spectral lines to determine moving towards or away. And this whole thing starts out with the idea of energy traveling through space in the form of waves. So there's lots of different energy traveling through space, and depending on the energy's strength, it has a varied wavelength. So we can see here, this is the visual of long wavelengths, and here we have the visual of short wavelengths. And so as energies change or the color changes for visible light, the wavelengths change too. Red is on the longer end of wavelengths, while this purple or blue is on the shorter end. So what does that even mean, long versus short energy wavelengths? Well, we know about this for a variety of different energies. We know about it for light energy, which we're talking about right now, and we also know about it for sound energy. And a great example is like a vehicle. So a vehicle emits sound, and as that sound is emitted, those wavelengths come off the object equally, right? It's a consistent sound, so they pulse out normally. But when that object starts to move, we see the wavelengths change based on our perspective. So here's a better example. Here's an ambulance traveling down the road. You can see as the object approaches the source or ourselves, we see those wavelengths shorter up front and longer behind. And we're seeing that same shift in light from stars. So this object, as it's moving forwards, has a shift to shorter wavelengths, or the blue end of the spectrum. And this object, from his perspective, as it moves away, shifts to the longer wavelength, or the red end. Now, we can't see it with our eyes like being shown in this example. What we have to see is these spectral lines. We do a comparison over time of an older view of a star spectrum. So maybe we gathered this in like the year 2000. And over time, we observe these spectral lines shifting in this view towards the blue end of the spectrum, right? These are the same two lines, but they've just shifted slightly towards this blue side or the shorter side, cluing us in that any stars with a blue shift move towards Earth. Where here, the original star spectrum, again, from the past, looking at it today, would show a shift towards the red. That would indicate to us that the wavelengths appear longer over time, meaning the star is moving away. So you have this really great diagram on your part 3, and we labeled up some key things. Here we can see this is, of course, the red shifts because of its coloring, and down here we have blue. Now looking at the spectra, or excuse me, the wavelength, we measure the difference or can see the difference. The red wavelength is showing longer. while the blue wavelength is showing shorter. And so again, what does that mean for the star's motion relative to you? Here we see the red, the star is moving away from Earth, and the blue is moving towards. So big picture, we want to be able to just understand what's being said. Redshift happens because the star is moving away from Earth. So the spectra have a shift to the red end. And we're seeing that here in this visual as well, right? The galaxy moving away shows a red, and towards is a blue. And so when you get to your learning target 6, you're using those same keywords, longer and shorter, when you're describing wavelength, and towards or away when you're describing motion of either a red shifted star or a blue shifted star. So kind of go half and half with your picture here and use these outlines that we made to really help elaborate your part 6.